Imagine a place where the very fabric of reality is twisted and torn, where gravity reigns supreme, a cosmic abyss from which nothing, not even light, can escape. Welcome to the world of black holes, the universe's ultimate enigmas. These invisible behemoths, lurking in the depths of space, have captivated scientists and stargazers alike for decades. What are these mysterious objects? How do they form? And what secrets do they hold about the nature of our universe? Join us as we embark on a journey to the edge of infinity, where we'll unravel the mysteries of black holes, explore their incredible properties, and discover the groundbreaking methods used to study these cosmic titans. A black hole is a region of space-time where gravity is so strong that nothing, not even light, can escape its pull. Imagine the Earth squeezed down to the size of a marble. That's the kind of extreme density we're talking about. This immense gravity is created by a massive amount of matter, compressed into an incredibly tiny space. At the heart of a black hole lies the singularity, a point of infinite density where all the matter is crushed. Surrounding the singularity is the event horizon, often described as the point of no return. Once you cross this boundary, there's no going back. The gravitational pull becomes so overwhelming that escape is impossible. The distance from the singularity to the event horizon is called the Schwarzschild radius. This radius depends on the mass of the black hole. The more massive the black hole, the larger its event horizon. Think of it as the black hole's sphere of influence. Anything that ventures too close to this sphere will be inexorably drawn inwards. Black holes aren't all the same. They come in different sizes, much like stars. Let's explore the main types. The most common type are stellar black holes. These are formed when massive stars, much larger than our Sun, reach the end of their lives and collapse under their own gravity. They typically have a mass a few times greater than our Sun. Then we have the giants, the supermassive black holes. These behemoths reside at the centers of most galaxies, including our own Milky Way. They can have masses millions or even billions of times greater than our Sun. Imagine the power of an object that massive. And finally, we have intermediate black holes. These are less common, and as the name suggests, fall between stellar and supermassive black holes in terms of mass. Scientists are still actively researching these mid-sized mysteries to understand their formation and role in the universe. The birth of a black hole is a dramatic event, a cosmic spectacle of destruction and creation. Let's explore the most common way these enigmatic objects are formed. It all begins with a star much more massive than our Sun. These stars live fast and die young. They burn through their nuclear fuel at an incredible rate, creating an outward pressure that counteracts the inward pull of gravity. But eventually, the fuel runs out. When this happens, the star can no longer support its own weight. Gravity takes over, and the core of the star collapses inwards. This collapse triggers a supernova, a spectacular explosion that blasts the outer layers of the star into space. For the most massive stars, the core collapse doesn't stop there. It continues to shrink, becoming denser and denser, until it's compressed into an infinitely small point, the singularity. A black hole is born. While supernovae are the most common way black holes form, there are other theories. Some scientists believe that supermassive black holes may form from the direct collapse of massive gas clouds, skipping the star phase altogether. This is still an area of active research. Black holes are invisible, shrouded in darkness. So how do we know they exist? Since they don't emit light, we have to rely on indirect methods to detect them. One way is by observing their effects on nearby matter. If a black hole is close to a star, its immense gravity can pull material away from the star, forming a swirling disk of superheated gas called an accretion disk. This disk emits intense X-rays that we can detect with space telescopes, revealing the presence of the hidden black hole. Another method is to observe the orbits of stars. If stars are orbiting an unseen object with extreme gravity, it's a strong indication that a black hole is lurking there. This is how we discovered the supermassive black hole at the center of our own galaxy. We can also use a phenomenon called gravitational lensing. A black hole's gravity can warp the fabric of space-time, bending the light from objects behind it. This creates a distorted image like looking through a magnifying glass, revealing the black hole's presence. Finally, We can detect gravitational waves, ripples in space-time caused by violent cosmic events like the collision of two black holes. These waves, predicted by Einstein, were first detected in 2015, providing direct evidence for the existence of black holes. Black holes are not just astronomical curiosities. They are also key to understanding one of the most important theories in physics, Einstein's theory of general relativity. General relativity tells us that gravity isn't a force, but a curvature of space-time caused by mass and energy. Imagine space-time as a trampoline. If you place a bowling ball on it, the trampoline will dip. That dip represents the curvature of space-time caused by the bowling ball's mass. Black holes, with their immense mass concentrated in a tiny space, create extreme curvatures in space-time. This curvature is so strong that it warps the path of light, creating the gravitational lensing effect we discussed earlier. Near a black hole, time itself is affected. Time slows down for an observer near a black hole compared to someone further away. This is called time dilation, and it's a direct consequence of general relativity. The singularity at the center of a black hole represents a point where the curvature of space-time becomes infinite. Our current laws of physics break down at the singularity, posing a significant challenge to our understanding of the universe. Let's explore some of the most famous black holes and the groundbreaking discoveries that have advanced our understanding of these cosmic wonders. Cygnus X1, one of the first black hole candidates, was discovered in the 1960s. It's a stellar black hole formed from the collapse of a massive star, and it provided early evidence for the existence of these objects. At the center of our own Milky Way galaxy lies Sagittarius A*, a supermassive black hole with a mass millions of times greater than our Sun. By observing the orbits of stars around Sagittarius A*, astronomers were able to confirm its existence and study its properties. In 2019, the Event Horizon Telescope achieved a remarkable feat, capturing the first ever image of a black hole's shadow. This image of the supermassive black hole at the center of the galaxy, M87, provided visual confirmation of Einstein's theories and opened a new era in black hole research. And finally, the detection of gravitational waves from merging black holes by the LIGO and Virgo observatories has provided further evidence for their existence and allowed us to study their properties in unprecedented detail. Despite all we've learned, black holes still hold many mysteries, pushing the boundaries of our understanding and driving further exploration. One of the biggest questions is, what happens inside a black hole? Beyond the event horizon lies the singularity, a realm where our current laws of physics break down. What happens to matter as it approaches the singularity? Does it get crushed out of existence, or is it transformed into something else entirely? Another puzzle is the information paradox. Quantum mechanics suggests that information is never lost, but general relativity implies that information can disappear inside a black hole. Resolving this paradox is a major challenge for theoretical physics. The formation and growth of supermassive black holes are also open questions. How did these colossal objects, millions or even billions of times the mass of our Sun, form in the early universe? To answer these questions, scientists are developing new missions and telescopes. The Event Horizon Telescope continues to observe black holes, while future missions like the James Webb Space Telescope and the Laser Interferometer Space Antenna, LISA, will provide new data and insights. The quest to understand black holes is an ongoing journey, pushing the limits of human ingenuity and our understanding of the cosmos. Our journey to the edge of infinity has taken us through the enigmatic world of black holes, from their formation to their profound effects on space-time. We've explored how these invisible giants are detected and how they challenge our understanding of the universe. Black holes are not just cosmic oddities, they are fundamental components of the cosmos, playing a crucial role in the evolution of galaxies. They are laboratories for testing our most fundamental theories about gravity, space, and time. The quest to understand black holes is a testament to human curiosity and our relentless pursuit of knowledge. And as we continue to explore the universe, these enigmatic objects will undoubtedly continue to captivate and inspire us. If you enjoyed this journey into the heart of darkness, Hit the like button and subscribe for more cosmic adventures. And let us know in the comments what other mysteries of the universe you'd like us to explore.